Okay, good morning, everybody. Before I jump into our slides, I do want to acknowledge all the hard work investing in making this project a reality, especially to community members and students outside of our project team. CalGrow, which is the entity I represent, was established in part through the networks we formed through this project with the goal of addressing barriers facing community design pollinator network and urban ag projects. We're currently working to establish a seed bank of regionally native plants and crop plants available to community-directed projects in LA and the SF Bay Area at a sliding cost scale. And I would like to invite anybody who has any questions regarding this project or our broader work to email me directly. I'll be dropping my email in the chat in just a moment. So this Parkway Potential project was developed around 3 key concerns expressed by community members in connection to a TreePeople canopy expansion project in South Los Angeles. These concerns focus in part on the soil's ability to support healthy tree growth with limited access to water, potentially creating a future liability for residents with trees in front of their homes. Soil health was also a concern specifically regarding possible soil contaminant presence and exposure through the act of gardening or planting. And some residents were questioning if trees might potentially impact mobility, mobility of contaminants in the soil. Lastly, community members prioritize tree plantings that would contribute to local efforts of establishing community produce hubs, either directly through the prioritization of fruit trees or indirectly by planting native and flowering plants and trees that could support pollinator networks across urban agricultural centers. Our goal for this project then was to test soil management practices in spaces impacted by the negative effects of urbanization in order to develop soil health remediation guidelines that could be used by community projects without the need for expensive techniques or specialized equipment. We wanted to assess how we could improve soil health in spaces with possible contamination, soil compaction, and low water availability to increase the productive capacity of the soil and ultimately improve tree resilience. To do this, we chose to test 4 soil treatments, and these treatments here are labeled with a 2 through 5 series with control representing treatment 1, so to speak. Treatment 2 on the top left introduced a 4-inch thick layer of mulch around the base of a new tree to a foot away from the trunk. Mulch here was only used as a surface treatment, not mixed into the soil profile. In addition to a mulch surface cover, treatment 3 introduced a compost amendment mixed into the soil to a depth of 16 inches and a 2-foot by 20-foot planting space before introducing the tree. We aim for a thoroughly mixed 4-to-1 soil compost ratio here. For treatment 4 on the bottom left, we tested the effectiveness of using mulch cover in addition to the introduction of 4 flowering native California plants with high pollinator support potential as living ground cover. The species we landed on were Salvia apiana, white sage, and Baccharis pilaris, coyote brush. In treatment 5, we tested the impact of mulch cover, compost amendment, and native companion plants all together at new tree growth, basically the works. And something I failed to include on this slide is that for all of the trees on all 25 sites, we selected Chilopsis linearis or desert willow trees. We selected these treatments in order to explore management techniques that help control heat flux, water availability, carbon content, and biodiversity in comparison to a tree planted without any treatments. Compost amendment and ground cover have also been used in the past to reduce possible contaminant presence although this was not specifically a part of our scope due to limitations in access to testing procedures for contaminants. In order to minimize costs, we sourced mulch and compost from LA Sanitation's community composting hubs. As you can see in this picture of control site B1, our control tests growth of a tree planted in bare soil with no amendments and no surface treatments. This 4 treatment versus control design was installed in 5 blocks across a 1 square mile area where TreePeople would be planting new Parkway tree in the community of Watts in South Los Angeles, which you can see on the bottom right here. After installing treatments, we collected baseline information on tree trunk diameter at rest height or DBH and canopy spread diameter for all 25 planted trees. We repeated these measurements again 6 months later to compare average rates of percent growth by treatment type and plotted the results. So here's a visualization. You can see 2 different treatments. The top is a control and the bottom is a compost and mulch amended tree. So here we're seeing an average percent growth of DBH in the top graph and crown diameter in the bottom graph by treatment type. As you can see for both graphs, control is represented in blue, mulch is red, mulch and compost in yellow, mulch and cover plants are represented in green, and mulch, compost, and cover plants in orange. We did find an impressive 93% growth in tree trunk diameter for trees planted with a mulch and compost amendment compared to only a 9% increase in the control sites. Canopy spread growth was greatest in the mulch only treatment at 121% growth compared to 20% growth in the control sites. We also did note that the introduction of native ground cover plants reduced the observed percent growth of mulch and compost treatments, most likely due to an increased demand for water in these sites. This may suggest the need to either plant native companion plants after trees have had the opportunity to establish, or increasing the amount of water given to trees planted with native companion plants in order to minimize the need for multiple plantings, which could be useful for logistics in these planting events. I was particularly impressed on the growth we saw in the ground cover plants themselves at this treatment site. On the right, you can see how small these white sage plants were when they were planted. They were planted directly from 4-inch pots into the earth, and after 4 months took off, as you can see in this picture on the left here. Although this companion plant growth is probably the result of scavenging water that might otherwise be available for the tree, I'm very curious in seeing how these plants are contributing to biodiversity in these plots, both above and below ground. When checking on these plots, it was impressive to see bees feeding from the sages and birds picking up the dried seeds. I'm also very curious in seeing how the tree growth relationship changes in these plots over time, especially after the companion plants have established to the point of not needing supplemental water, since California native plants are known for being thirsty in an establishment period. Ultimately, the lessons we learned in just establishing logistics for this project provided very useful information for future project designs, which should be of good utility when it comes to scaling efforts in urban settings for these types of projects. Hopefully, we'll be able to see how these metrics change with an increased scope, both spatially and with changing variables such as tree species and companion plant selection, depending on community goals and priorities. We did meet, for example, a Southeast Los Angeles resident who was interested in the possible application of her research using native plants to immobilize lead in the soil with this Parkway potential project or similar style projects. And these are opportunities and goals that CalGrow will definitely be interested in exploring moving forward. I also quickly wanted to share this snapshot from the Theodore Payne Foundation newsletter regarding the LA County Biodiversity Motion to emphasize this kind of emergent need for urban green infrastructure research. These projects have the potential to play a significant role in influencing new policy and are important when it comes to elevating and contextualizing community identified priorities, especially as public entities move to require basically scaled implementation of biodiversity initiatives. As a community member expressed to me, each tree that is planted that does not help meet community goals represents an opportunity taken away. So hopefully we'll see an increase in the amount of participatory research emerging from urban centers in connection with these initiatives to ensure that these projects meet local priorities. So in addition to the above ground metrics that we covered a couple slides back, we were able to collect below ground data and characterizations with the help of UC Riverside. In order to cover that work, I'll go ahead and hand the mic back over to our host and Dr. Irmis for UC Riverside.